So far we have learned that when we know two properties, we can find other properties, and with two properties, we can help define a state of a system. Now in this question, a tank contains two-phase liquid vapor mixture, refrigerant R22 at 10 bar. The mass of saturated liquid in the tank is 25 kg and the quality is 60%. Determine the volume of the tank in meter cube and the fraction of the total volume occupied by saturated vapor. So first we have to find out. So the gas is R22 and the pressure is 10 bar. Mass of liquid is 25 kg and the quality is 0.6. So the first thing we have to find is volume of the tank. And the fraction of the total volume occupied by, and then we need to find fraction of the total volume occupied. So the quality is given by mass of vapor divided by mass of liquid and mass of vapor. So the only unknown in this equation is mass of vapor. So if we substitute all the values, we get mass of vapor to be 37.5 kgs. Next, we need to find what is the
ये बोर्ड शो नहीं हो रहा.
Now is it visible?
Yes.
So after finding the mass of vapor, we have to find the specific volume of the mixture. The specific volume of the mixture formula is that Vf plus X into Vg minus Vf. So all these values Vf and Vg are available from the tables at the pressure of 10 bar. Now if we go in the tables, at the pressure of 10 bar, look at the bottommost specific volume. So pressure of 10 bar, and we need to find for refrigerant R22. So if we go and main table, and refrigerant R22 pressure table is table A8. So table A8 on page 938. So and at 10 bar, if you look at the bottommost line, 10 bar, the specific volume is 0.8352 to 10 raised to the minus 3, and Vg is 0.0236. So if we substitute both of these values in the equation, we get V mixture to be 0.01449 meter cube per kg. Now the volume of the tank is V mixture into the total mass of the tank. So this total mass of the tank is mass of vapor, which we calculated above, plus mass of liquid which was given. So volume of the tank comes out to be 0.9056 meter cube. Next is fraction of the volume occupied by water vapor. So fraction of the volume occupied by water vapor. So if we draw this on a TV diagram, so this distance from here to here is Vf. That is the specific volume of the liquid. Next, this distance is the volume occupied by, so this distance is 0.6 into Vg minus Vf. This is Vg minus Vf. So fraction of the volume occupied by water vapor is x into Vg minus Vf divided by V total. So the numerator is, we have to multiply numerator with mass of vapor to get volume. So the fraction of the volume occupied by water vapor is 0.57. So first we applied the quality equation, then we found specific volume of the mixture. We multiplied specific volume of the mixture with total mass to obtain total volume, and then the mass fraction of the water vapor was found by first finding the volume of the vapor, and then we divided it by total volume. Now the next question is about ammonia. Initially at 6 bar 40 degrees Celsius, undergoes a constant volume process to final pressure of 3 bar. At the final state, determine temperature and quality. Locate each state on the TV diagram. So we have to locate it on a TV diagram. This is ammonia. So the process is a vertical line because it's a constant volume process, and it's a vertical line which is direction of it is downwards. However, we are not sure whether the initial state is at superheated or whether the final state is in superheated or mixed vapor. To determine the initial and final state, we need to consult the tables. So 6 bar and 40 degrees Celsius. So 6 bar and we have to find the final temperature and the quality. So they've asked us to find quality in the final state, which means that the final state is in the mixed vapor region. And how will we be able to find quality? We will be able to find quality by equating V1 equals to V2, that the initial volume, specific volume, equals final specific volume. So the initial specific volume we will be able to find out by the table. So 6 bar and 40 degree Celsius. So let's again go to the initial table. So a refrigerant ammonia. Okay, so table 950 is a superheated ammonia table. Then there is table A13, which is temperature table. Table A14 is pressure table. We are given both temperature and pressure. So we can start by consulting both the tables. So let's consult the temperature table first. Sorry, it's ammonia, so it is table A13, 948 page. So let's type here 948. So 40 degree Celsius. 40 degree Celsius, the pressure is 15.549. So if we draw this, so if this was line of constant pressure, so 6 bar and 40 degree Celsius. So if this temperature is 40 degrees Celsius, then this line of constant pressure is 15.549 bar. This line is 15.549 bar. Now in our question we are given line of 6 bar. So if we draw line of 6 bar, it would be somewhere below the above line. So 6 bar is below it.
सर आपकी बात नहीं आ रही.
So line of constant.
Sir,
So
line
line
of
of
constant
constant
pressure.
line of constant
Open.
pressure would be below 6 bar would be below 15.549 bar.
Sir, line of constant pressure
नहीं शो नहीं हो रही.
की तरफ और right of the top की तरफ
हो जाती है.
So line of constant pressure, there is one correction here to make. So line of constant pressure is upward sloping. So if we consult the tables, so at 40 degrees Celsius, the corresponding pressure is 15.549 bar. So if we consult this table, so at 40 degrees Celsius, this is 40 degrees Celsius, then this pressure line is 15.49 bar, and line of 6 bar would be below this 15.49. So 40 degrees Celsius and 6 bar lies in the superheated region. So from there we have a constant specific volume process. So it would be a downward line. It would be a downward line, and it will end in the mixed vapor region. So we need to redraw this. That we end up in the mixed vapor region. So if we consult the table, so 6 bar and 40 degrees Celsius for superheated ammonia. If we keep on going down, the 6 bar and 40 degrees Celsius. The specific volume is 0.24118. The specific volume is V1 is 0.24118 meter cube per kg, and constant specific volume process, so V2 equals V1. Now at the final state, it's in the mixed vapor region, so we need to find the temperature in the final state such that the specific volume of it is V1 and the pressure is 3 bar. So if we consult the tables again, at 3 bar, so at 3 bar the specific VF is, temperature is minus 9.24, so that is the answer, minus 9.2, and we know VF and VG. So if we use VF and VG, so temperature is minus 9.24, and if we in degree Celsius, and if we use VF and VG, we can find the quality, and the quality comes out to be 0.5925.
लास्ट स्टेप की नहीं समझ आई.
So the quality formula for it is VG, so X equals VF plus X plus X into VG minus VF. Now VF and VG we can obtain from the tables corresponding to the pressure of 3 bar. From the pressure table of ammonia we can obtain VF and VG. The only unknown in this equation is VF and VG. Now the next question is 1 kg of water initially at critical point. So at 1 kg of water at critical point, if the water is cooled at constant specific volume to a final pressure of 30 bar, determine the quality at the final state. So there is 1 kg of water at critical point. So temperature versus specific volume. The critical point is the highest point inside the vapor dome. Critical point is the highest point. The coordinates of the critical point can be found out from table A1. On table A1 we can find all the coordinates of the critical point. So in the critical point we have, if we use this formula, so if we use this formula, ZC can be found out from table A1. ZC, PC, TC, and R is universal gas constant. The value of R is R bar over molar mass, and the value of R bar is 8314, and the molar mass of water is 18.02. So all the values can be found out from table A1 except VC. So VC comes out to be 3.15 into 10 raised to power minus 3 meter cube per kg. So at state 2, it is a at state 2 it is a constant. So the process from critical point to the state number 2 is a vertical line. So we have found out V1, which is Vc. So V2 equals V1, but the pressure at point 2 is 30 bar. So just like the last question, we can find the quality of it at the second point. So the quality comes out to be 0.0296. Now at state 3, the process at state 3. So we read part B. If the water undergoes a constant temperature expansion to a pressure of 30 bar, determine the specific volume at final state. Now instead of constant volume process, we have a constant temperature expansion, which means that instead of going 1 to 2, we go 1 to 3, a constant temperature expansion. And at 3, what do we know? We know the temperature. The temperature of it is equals to Tc. This we obtain from table A1, and we know the pressure is 30 bar. So from the superheated table, we can obtain the specific volume at 3, which is 0.0948 meter cube kg. Now in this class, we further try to find out properties, and we moved from the properties of water and we found properties of ammonia, refrigerant R22.